Hey, welcome back. This is part two video on Law of Sines. In the first video, I had covered SAA type of triangle and ASA type of triangle, giving two examples. Please notice how in SAA triangle, and actually both of these type of triangles, two angles are going to be provided to us. So these are relatively easier ones. If two angles are given to me, we can just use the property of 180 degrees sum of the triangle and quickly find the third side, and then do law of sine to find the other two sides. Now, this video specifically only covers SSA type of triangle. This is also referred to as the ambiguous case, and hence ambiguous or US. This is also referred to as the ambiguous case, and hence the video could get a little longer. We'll see. But I'm only focusing on SSA. Okay, moving on one more time. I did show in the last video, these are the three types where law of sine works out easily. These two are the next lesson where law of sine doesn't work to begin with, but law of cosine works to start off with, and then we can switch to law of sine or Pythagorean, however it goes. So let's go ahead, and of course, here's our law of sine formula. We covered this, and here we go. Like I said, we're solving SSA. If you read it backwards, yes, it does turn out to be ASS. I'm not going to be using that word. It does turn out to be an English word. However, if you want to remember this using the ASS type, it's totally cool because this type of triangle does stand out. Now, let me tell you why it stands out and why this is so special, because you got to be a little careful while working with them. Excuse me. All right, so an angle is going to be given to me. Let's call that angle A. Let's say angle A is provided. Then one of the other sides will be available. If this would be angle B, then let's call this side angle B. Let's call this the altitude or the height of the triangle. So that's one S is available, calling it B. Then the third side available to us would be another one here. So let's call it side A. Has to be side A because it's opposite to angle A. Now what happens is, one of the special cases is if A, like as you can see, is too short. Now short as compared to what? If A is less than the height of the triangle, we are not going to be able to construct a triangle. Very important, let me repeat. If A is less than the height of the triangle, like as you can see, like I can extend it and make it up till here or here or here. If it's less than the height of the triangle, side A is not going to be able to reach out to the other side to be able to complete the triangle. When that happens, we call it a case where no triangle exists, and that would be the first situation. I'm going to try my best to show you it visually. Like I said, that's going to be the first possibility. Now, we will not be able to draw the triangle, or we will not be able to figure it out until we do the math with it. Of course, I'll show you the math, but this concept is really important so you understand what's going on with the ASS type of triangles. The second possibility is, and again, we are fixed with angle A. So angle A, I'm going to try and draw the exact same measurement to the best of my ability. Angle A is provided to us, whatever it is, 53 degrees, 67 degrees, whatever it is. This would be angle B. This had to be side B. Side B will also be provided to us. And of course, this is the height of the triangle. The second situation is if side A, which is on this side, if that side is greater than the height of the triangle, which means I can't totally continue this. If this is greater than the height of the triangle, let's say right here, that's side A. Now you can clearly see A has to be greater than the height of the triangle because in half of this triangle, like in this triangle here, A is the hypotenuse, so hypotenuse has to be more than the height. So A is greater than H. When that happens, we clearly get a triangle. We definitely are able to form a triangle. We should be able to find the other angle, which should be C here. This should be side C here. We should be able to calculate all of them and solve a triangle. However, with that same measurement of A, that A could sit here on this side. That A could also go sit here on this side. And now assume that the blue line and the green line, the A measure is the same because it is the same A. It can lead to two triangles. Let me separate the triangles. I'm going to try my best here to redraw it. With the same angle A, same side B, we don't know the angle B, and here's the height. Now that A, instead of going and sitting on this side, could actually be on this side. Then this would not be B. This would be angle B. This would be angle C. That would be side A. This would be side C. And notice how both these A measurements are the exact same. When does this happen? This only happens if A is greater than the height of the triangle, but at the same time, it's less than the other given side B. Here's a specific case. So this is a situation when we end up with two possible triangles, and we will have to find both of them. It could be either or this one, and we will have to find both of them, and that creates a little more work with that type. And the third possibility could be, I'm going to keep it the same. Let's pretend this A angle is the same angle given to us. Say this is side B, angle B, sorry, side B, height of the triangle. Okay. Now, what if that side C is a super long side? When I say super long, as compared to what? If C is greater than H, has to be greater than H, and at the same time, it's longer than B, the other side. So, and also C is greater than B. Let's pretend long C here. There we go. Then we can only possibly get one triangle. Let me finish this off here. B, erase that. And this would be, no, that would be side A. That would be angle C and side C. So you can clearly see how A is greater than H for sure, but not only that, it's greater than B. Then we can only possibly get one triangle, and we will be solving for that particular one triangle. And that's what makes ASS special, because of these three possible cases. And the big name for this given is the ambiguous case, because we don't know until we actually solve it as to if you're going to get one triangle, two triangles, or no triangle. So let's proceed how to solve them. Hopefully this makes sense. This is explaining the same thing. All right, let's try this. Use the law of sine to solve the SSA type of triangle. So please identify, this is the ASS type. This one tells me there's one solution, but you wouldn't know that on assessments. Neither would I. So to the best of our ability, let's draw a triangle. A, B, C is 3, 2, and angle A is 40. One more time, this wouldn't be given to me. So when I look at this triangle, I would say to myself that I've been provided one angle and two sides, and the angle is not included angle, so it's the ASS type. And then I'll be like, okay, wait a second, gotta do this very carefully. All right, like I said in the previous video, how do I know I can use law of sine? Just look for an angle side pair. Do I have an angle side pair available? Yes, I do have an angle side pair available. Now look at the other pair. I have that angle missing, but I do have the side. So I have three of the four quantities I can use to set up the formula. So number one, let's try and find angle B. Sine A over A equals sine B over B. Now to find sine B, like I said in the previous video, you will cross multiply these two and divide by that. So sine B will equal over 3, and sine B will be equal to, let's do that math, it will be approximately equal to 0.043 in yada yada yada. Now wait and watch here. Sine of B is equal to that. There's this whole separate understanding of unit circle that we're going to apply here. So the sine value given to me is a positive value, 0.43. There could be an angle here. There has to be an angle here where the sine value, which is the y coordinate, will be 0.43, that angle. And now do know sine is also going to be positive here at some angle, and that angle would be referred to by this angle. And the sine value will be the exact same here. Remember, both sine values are positive, so sine values are positive in quadrant 1 and 2. So there are actually two angles, and I got to find both of those angles. When I plug in B equals sine inverse of that 0.043, and I'm going to use the entire number, calculator is going to give me one angle only. So B equals about 25.4 degrees when you plug this into the calculator. So this first angle is 25.4. A calculator is not going to give me the second angle. So we have to find one possibility of first angle is B1. The other possibility of that angle, calculator, one more time, calculator will not give you two answers. You have to realize that, oh, there has to be a second angle which has the same sine value. How do I find this blue angle? This is the angle I'm talking about. Now I have to find this angle. Now, if we understand the concept, that's a 180-degree line. Subtract 25.4 from it, which is the same as this one. If you subtract 25.4 from it, you'll get this other blue angle. So let's do that. 180 minus 25.4 gives me 154.6 degrees. So those are the two possible values of angle B. This angle B could be this or this. Now let's make sense out of it. Angle A, I'm going to go ahead and do my little thingy that I do. Angle A is 40. B is what we're trying to find. C, we still don't know yet. Side A, side B, and side C. Don't know it. So one possibility of B, like I said, is 25.4. Now look at angle A and look at angle B. They both add up to about 65 degrees, right? So if they add up to 65 degrees, I can clearly find a third. There's a possibility of a third angle being present, which would be 180 minus 40 minus 25.4. That will lead to 114.6. Now the other possible value of B that I just figured out is 154. B2 would be 154.6. So if angle A is already 40-degree angle, and angle B comes in with a 154-degree measurement, if you add the two, that's already above 160, 180. So the sum of these two, 40 plus 154.6, angle A and angle B, is already greater than 180 degrees. So that's not possible. And hence we reject the other one. Now, in the next example, we will not be able to reject the other one. So please be careful with this part. And just based off of that, I'm going to cross this out, that this is not possible, which tells me there is only one possibility of B, which I already wrote in my box here, which means there's only one possibility of C, and I already found that. And I already found angle B. Go ahead and write that down here, 25.4, 114.6. Now I need to find part 2. Now I need to find side C. That's about it. Once I find side C, I should be good to go. I'm going to use the same setup. Sine A over A equals sine C. Now I do know angle C over side C, which is what I'm trying to find. C would be equal to the product of 3 and sine 114.6 divided by sine of 40 degrees. Plug that into the calculator while in degree mode, and it would turn out to be approximately 4.24. 4.24. And we are done with this problem. Hence, we will state that this was the one that only had one possible triangle, one solution, and we have solved it. My box completes all that information, and then we've almost labeled it. Let me go ahead and label it here, and there we go. Our triangle is solved. Hope that made sense. Let me move on to the next example where there are two possible solutions, so that one's going to be longer. There we go. A, angle B, don't know. Time to draw it. Something like that. We don't know if it's exactly like that, but generally we start off. All right. So the first thing when I draw this, I'm like, oh wait, this is the ASS type. There's an angle and two non-inclusive sides. So I got to be very careful, and hence we start solving it. Of course, I do have an angle side pair here, and then I would start off with this. So our first objective will be to try and find angle B. So step number 1, law of sine. Sine A over A must equal sine B over B, cross multiply, sine of B must equal 8 times sine 35 degrees over 6. Let's find the value of this. Okay, and that turns out to be approximately 0.76. And again, the exact same concept comes in here, that sine value is positive at two different angles. I'm going to go ahead and erase that later, but because we know sine value is 1 here, so 0.76 has to be in the first quadrant, not 0, but some x value and y value. So this will be our first angle, and the second angle would be here somewhere. That would be my second angle, where y will have the exact same value. So let's go ahead and plug it into the calculator. I'm going to plug in B1. I'm going to call it B. I'm going to plug in sine inverse of that number, and I will not round it much. Possible B1 angle is, let's see, this one's giving me 49.9, so 49.9 degrees. So that's one possibility of angle B. I'm going to go ahead and write it here. And that works out fine because 49 and then 35, 49 and 35, they clearly create enough room for a third angle, 49.9, being 95.1. So clearly I have enough room to create a third angle. So that makes sense. Now let's find the other angle. What is the other possibility of B2? Which would be 180 minus 49.9. Possibility of B2 turns out to be 14. Not 14. Let's do this. 180 minus 49.9 leads me to 130.1 degrees. So if this is B1, then B2 looks like could possibly be 130.1 degrees. And if A, like I said, is 35, and there's no need to write it again actually. So I'm using this A and this B. Let's add them up. Does that create enough room to create a third triangle? Plus 35 is 165.1. So yes, we do have enough room. 180 minus 130.1 minus 35 degrees. That leads to 14.9. So now I have to change gears and I have to go, that's a possible C1 and a possible C2 is 14.9. And maybe I will rewrite it here. So you can see there are actually two possibilities of angle B and two possibilities of angle C. Erase that. Which means this C will have, I'll have to calculate it carefully. There will be two possible values of C as well. Okay, let's do it. So accepted, right? And then B2 also accepted. Okay, secondly, I'll have to start finding C, this little C, the side C, which is this C right here, of one based off of B1 B, and C1, and one based off of B2 and C2. So sine A over A must equal sine C1, I'm going to try the first one first, 91.5.1 over C, little c1. So C1 would equal divided by sine of 35 degrees. This C1, once plugged in, will get me about 10.42 as the length of C. C1, oopsies, I don't know what I'm doing. Sorry, 10.42, not negative, but positive. That's possibility C1. And the other setup would be sine 35 sine A over A, because the angle A and side A are fixed. They're not going to change. Over the second possibility of angle C, which is 14.9 over C2. If that was the case, then what would C2 be? Cross multiply, divided by sine of 35 degrees. That turns out to be approximately 2.69. So another possibility of that side could be 2.69. So if I were to create two triangles, actually I should create two tables. 35, A6, B2 could be 130.1, C2 could be 14.9, and then base B didn't change, obviously. And based off of this, C2 could possibly be 2.69. So that's off of the table. Technically, we should also try and draw the triangle. Now that there's not one triangle, because I started off with one, but we realized there are actually two of them. So I could go ahead and say the first one would be 10.42 with a C value of 95.1 degrees and B value 49.9. And the other one, if you notice, the other B angle is an obtuse angle. So I have to kind of make an obtuse angle at B. So this one is 130.1. Both A and C are acute angles, which makes sense. So 35 here, 14.9 here. B is 8. C would be 2.69. And A is still 6. That the triangles aren't very accurate because I did it by hand. But the idea is that there will be two possible triangles with those measurements. So that takes care of this question. And I know the video is already long, but I also want to show you a possibility when there is absolutely no solution. How would you figure that out? This should be quick because we quickly run into a situation where the math does not work out. And then A, there we go. Okay, in this case, if you notice, again, it's ASS, of course, but this is the angle side pair available to me. So I'm going to start with angle C, and then A is what I'm going to start with. So sine of 50 degrees over A must equal sine of, over C, this was C, over sine of A over 2. When I cross multiply, sine A turns out to be 2 times sine of 50 degrees over 1. I really don't have to write 1. Let's figure out what that value is. 2 times sine of 50 when done on the calculator turns out to be approximately equal to 1.53. Now you can realize it at this point in time that sine values are cannot be greater than 1. They basically range between -1 and 1. So you can tell right away that A is not going to be possible. But let's say you end up plugging A in to the calculator to find A. You're going to plug in sine inverse of 1.53, and the calculator will also generate an error because that's not possible. And then you would know right away that there are no solutions or no triangles possible. Reason being, this one is going to be too small. The third side, this one is going to be too small. It's actually not going to touch. Like it'll be about this much. It's 2, it's 50, and 1. And it won't be able to connect to the third side. So those were the three possible cases, ambiguous cases, and that should wrap up our law of sine. All right, see you later. Bye.